Hi, my name is Marsh Hamidani, and I'm going to be your instructor over the next few hours. In this course, you're going to learn everything about Angular from the basic to the advanced topics, and you will build and deploy a real e-commerce application using Angular, Firebase, and the new awesome Bootstrap 4. Let me show you a demo of this application real quick. We're going to build an e-commerce application for an imaginary organic shop. So here on the homepage, we have master detail. We can select a category and see all the products in that category. We can add a product to our shopping cart, change the quantity, and the number of items in the shopping cart gets updated in real time. And here's our shopping cart. Again, here we can change the quantity for each item and the total price, as well as the total number of items in the shopping cart, get updated immediately. If I open another tab and add another product to our shopping cart, what we have on the shopping cart tab gets updated automatically without me having to refresh the page. So all the data we show to the user is in sync everywhere in the application. And this is the beauty of a real-time application. Now let's check out. Here we have a shipping form and the summary of all the products in our shopping cart. And again, this summary gets updated as soon as I make a change to our shopping cart in another tab. Once we place this order, it will be visible to our admins. So I'm an admin user and I have this menu here, Manage Orders. Here we can see all the orders in the application. Other users will not see this page here. So here we have authentication and authorization. As an admin, I can also manage the products. So here we have all the CRUD operations. We can quickly search for a product. We can sort the data, resize the columns, or navigate to a different page. These are the patterns that you see in a lot of real-world applications. And in this course, you're going to learn how to implement these patterns in your applications. So, are you excited to learn Angular and build this application? Then let's jump in and get started. So, in case you're an absolute beginner with Angular, let me quickly explain in 2 minutes what Angular is and why you should learn it. Angular is a framework for building client applications in HTML, CSS, and either JavaScript or a language like TypeScript that compiles to JavaScript. But TypeScript is more common in the Angular community because Angular itself has been written with TypeScript. Now, if you have never worked with TypeScript before, don't worry at all. It's very easy and you're going to get familiar with it in this course. Now, one question that a lot of beginners have is, why do we need Angular? Can we not use plain old JavaScript or jQuery? We certainly can, and that's how a lot of web applications out there are built. But as our applications get more complex, vanilla JavaScript or jQuery code becomes hard to maintain. We need a way to properly structure our application. Sure, there are JavaScript patterns out there that help us with the structuring, but these patterns are hard to understand for a lot of beginners to JavaScript. Plus, a lot of applications built with vanilla JavaScript or jQuery are hard to test. And that's why, over the past few years, various frameworks have been built and evolved to make web application development easier. Angular is an example of such frameworks. It gives our applications a clean and loosely coupled structure that is easy to understand and easy to maintain. It also brings in a lot of utility code that we can reuse in various applications, especially when dealing with the user's navigation and the browser history. Plus, applications built with Angular are more testable, so we can easily write automated tests to test various parts of our application, as I will show you later in the course. So to answer this question, no, you don't need a framework like Angular to build client applications, but using Angular makes your life a lot easier. All right, now that you know what Angular is, let's take a look at the architecture of Angular applications. A lot of modern applications have at least two parts, a front end and a back end. The front end, also called the client, is the part that runs in the web browser, and this is what the user sees and interacts with. So it essentially includes the user interface or UI of an application. We use HTML, CSS, TypeScript, and Angular to build the front end. The backend sits on a web server or multiple web servers in the cloud and is responsible for storing the data and doing any kind of processing. Our front end or the client app talks to the backend to get or save the data. One of the questions that a lot of beginners ask me is, Mosh, how do I save my data in Angular? Well, you don't. In most cases, you don't save the data on the client because it can easily disappear as the user clears the browser data or moves to a different computer. That's why we store the data on the server. So here we often have one or more databases, as well as a bunch of HTTP services or APIs to make this data available to the clients. In case you don't know, API stands for Application Programming Interface. Now, if you put this fancy name aside, these HTTP services or APIs are essentially endpoints that are accessible via the HTTP protocol. So we can call them using simple HTTP requests to get or to save the data. If that's too much technical jargon here, let me give you a metaphor. Think of a port where ships load or unload. These are points to get loads in and out of a town, right? Now imagine these ports are HTTP endpoints, ships are HTTP requests, and loads are data. So just like we can send a ship to a port to get some load and bring to us, a client app sends an HTTP request to an endpoint to get some data. So this is how the big picture works. Our web applications have a front end and a back end. On the back end, we have one or more databases and APIs that make the data available to the clients. For a large application around a complex domain, this is where we implement the business logic of the application, like calculating the tax and shipping cost based on various parameters. The front end or the client, on the other hand, is all about the presentation. So here we have our HTML templates, as well as the presentation logic of our application. This logic is all about displaying data and responding to user actions, like what should happen when the user clicks on a button or navigates away from a page. These are examples of the presentation logic, or the logic that is all about the presentation aspect of an application. Now, in terms of the implementation, building the backend requires familiarity with other languages and frameworks, and that's completely outside the scope of building client apps with Angular. So as an Angular or a front-end developer, you don't have to worry about this. This is the job of a backend developer or a full-stack developer who knows both the front end and the back end. So for the purpose of this course, we're going to focus on the front end. And if you want to learn about the backend development, you can always pick up a course later down the road. But for now, let's just focus on one thing and do it well. All right, in this lecture, I'm going to show you how to set up your development environment and create your first Angular project. So the first thing you need to install is the latest version of Node. In case you have never worked with Node before, it's basically a runtime environment for executing JavaScript code outside the browser. In this course, we're not going to work with Node, but Node provides some tools that we need to build Angular projects. So if you haven't installed Node, head over to nodejs.org. On this page, you can see the latest version of Node for your operating system. So here, the latest stable version is 6.11, and the latest version is version 8. Now, this latest version has more features, but it's not quite stable yet. So go ahead and install the latest stable version. When you do that, open up the terminal on Mac or command prompt on Windows and type node --version. So you can see on my machine, I'm running Node version 6.10. The minimum version required for building Angular applications is version 6.9. Once you have Node, then we're going to use a tool called Node Package Manager, or NPM, to install third-party libraries. One of those libraries we're going to install in this lecture is Angular CLI, which stands for Command Line Interface. So it's a command line tool that we use to create a new Angular project or generate some boilerplate code, as well as create deployable packages. So once again, in the terminal, we run npm install -g, which stands for global, and finally the name of the package, which is @angular/CLI. If you don't put -g here, Angular CLI will be installed only in the current folder, and it's not going to be accessible anywhere else. Now, if you're on Mac, you need to put sudo at the beginning of this command to execute it as an administrator. All right, next we need to enter our password. And now this process is going to take a little while. All right, beautiful. We installed Angular CLI. Now to ensure that the installation was successful, we can type ng --version. So you can see I'm running Angular CLI version 1.1.0. And below that, you can see the version of Node on my machine. Once again, it's 6.10. So with Angular CLI in place, now we can create a new Angular project. So we type ng new, and let's call this project hello-world. So this generates a bunch of files and folders, and then it's going to use npm to download the third-party libraries. All right, our project is successfully created. Now to start coding, we need a code editor. The editor I'm going to use in this course is Visual Studio Code or VS Code. It's a beautiful cross-platform lightweight editor that you can download at code.visualstudio.com. If you don't like this editor, feel free to use any editors that you prefer. You can use Sublime, you can use Atom, or any other editors. Now, if you're going to use VS Code, I want you to add it to the path so you can easily open it from the terminal. So here, if you're using Mac, press Shift, Command, and P. Or if you're using Windows, press Shift, Control, and P. This opens up the command palette. Now here type code. Look at this command here. Install code command in path. With this, we can go to the terminal. In the folder where we created a new project, Hello World, simply type code period. So this opens up VS Code pointing to the current folder. Now in the next lecture, we're going to look at this structure. You're going to learn what files and folders we have here. But before we get there, let's make sure that this application works. So back in the terminal, once again, we use Angular CLI to load our application in a web server. So we type ng space serve. So now we have a live development server listening on localhost port 4200, and Angular CLI also compiled our application. It generated bundles for JavaScript and CSS files. So we can open up Chrome and head over to localhost port 4200. Beautiful. This is our first Angular app. Next, we're going to look at the structure of our new Angular project. All right, now let's see what files and folders we have in this new project. So the first folder we have here is E2E, which stands for end-to-end. And this is where we write end-to-end tests for our application. If you have not worked with end-to-end tests, these are basically automated tests that simulate a real user. So we can write code to launch our browser, navigate to the homepage of our application, click a few links here and there, fill out a form, click a button, and then assert that there is something on the page. This is an example of an end-to-end test. Now that's beyond the scope of this course, so we don't have to worry about it yet. Below that, we have Node modules. And this is where we store all the third-party libraries that our application may depend upon. Now this folder is purely for development. So when we compile our application, parts of these third-party libraries are put in a bundle and deployed with our application. So we're not going to deploy this Node modules folder to a server. You're going to see this later in the course. Below that, we have the source folder. And this is where we have the actual source code of our application. So we have this app folder here, and inside this folder, we have a module and a component. So every application has at least one module and one component. You're going to get familiar with these components and modules very soon. Below that, we have this assets folder where you store the static assets of our application. So if you have any image files, any text files, any icons, all of these go here. Below that, we have this environments folder. And this is where we store configuration settings for different environments. So we have one file for the production environment and the other for the development environment. Now, the other files we have in the source folder are favorite icon, which is the icon displayed in the browser. We have index.html, which is a very simple HTML file that contains our Angular application. So note that here we don't have any references to a script or a style sheet. These references will be dynamically inserted into this page, as I will show you later in the course. Now, below that, we have this main file, which is a TypeScript file. And this is basically the starting point of our application. So in a lot of programming languages, we have this concept of the main method, which is the starting point of a program. We have the same concept in our Angular applications. So all we're doing here is bootstrapping the main module of our application, which is in this case, app module. So Angular loads this module and everything else starts from there. We have this polyfills file, which basically imports some scripts that are required for running Angular, because the Angular framework uses features of JavaScript that are not available in the current version of JavaScript supported by most browsers out there. So these polyfills fill the gap between the features of JavaScript that Angular needs and the features supported by the current browsers. Below that, we have styles.css, and this is where we add the global styles for our application. And also each page or each component can have its own styles, as you will see later in the course. Below that, we have test.ts, which is basically used for setting up our testing environment. Again, for now, we don't have to worry about this. Now, outside the source folder, we have a configuration file for Angular CLI. It's pretty standard configuration. You don't have to worry about it for the most part. Below that, we have editor config. So if you're working in a team environment, you want to make sure that all developers in the team use the same settings in their editors. So this is where you store these settings. We have this git ignore file, which is basically for excluding certain files and folders from your Git repository. If you have not worked with Git, don't worry. It's not something that you need to know in order to build applications with Angular. It's basically a tool for managing and versioning your source code. Now below that, we have karma.config.js, which is a configuration file for Karma, which is a test runner for JavaScript code. Again, we're not going to worry about running tests at this stage. Now below that, we have an important file, package.json. Now this is a standard file that every Node project has. Apart from a bunch of basic settings here, like the name and version of your application, we have this setting here, dependencies, which determines the libraries that your application is dependent upon. So here you can see we have 9 references to Angular libraries. All these libraries start with @Angular, and after that we have the name of the library. So the first library here is for animations. If you're not going to use animations in your application, you can delete this here. So in the future, as we use third-party libraries, you will see them listed here under the dependencies. Now below that, we also have another setting or another key called dev dependencies. And these are the libraries that we need in order to develop this application. So we don't need these to run our application on a production server. These are purely for a developer machine. So here we have a reference to Angular CLI, which you're already familiar with. We also have a few other references to Karma, which is again a test runner for JavaScript code. Now below this package.json, we have protractor.config.js, which is basically a tool for running end-to-end tests for Angular. Again, we're not going to worry about it. Now, another file here is tsconfig, which has a bunch of settings for your TypeScript compiler. So your TypeScript compiler looks at these settings, and based on these settings, is going to compile your TypeScript code into JavaScript that browsers can understand. Again, for the most part, you don't have to change any of this here. Just be aware that if in the future, in a complex project, you need to change your TypeScript compiler settings, this is where you need to apply your changes. And finally, we have tslint.json, which includes a number of settings for tslint. In case you don't know, tslint is a static analysis tool for TypeScript code. So it checks your TypeScript code for readability, maintainability, and functionality errors. So this is the basic structure of an Angular project. All right, now let's make a tiny change to this application. So in the app folder, open up app.component.ts. Now, if you have never worked with TypeScript before, don't worry about this code. As we go through the course, I'm going to break this up for you so you will know exactly what is happening here. So all I want you to do here is to change this string from app to Angular app. Now save the file. Back in the terminal, look at this message, Webpack compiling. So Angular CLI uses a tool called Webpack, which is a build automation tool. It gets all our scripts and style sheets, combines them, puts them in a bundle, and then minifies that bundle. And this is for optimization. So here you can see we have a few bundles like polyfills, which includes all the scripts to fill the gap between the version of JavaScript that Angular needs and the version of JavaScript supported by most browsers out there. We have main bundle, which is all the source code of our application. We have styles bundle, which includes all our style sheets. And note that here style sheets are actually stored in a JavaScript bundle. You're going to see that in a second. We also have this vendor bundle, which includes all the third-party libraries. Now, at the time of recording this video, unfortunately, Angular CLI does not allow you to customize the name of these bundles or add additional bundles. But there is a discussion going on GitHub. Chances are this may change in the future. Now, that aside, what I want you to note here is that whenever you change one of your files, whether that file being a style sheet, a TypeScript file, or an HTML file, Webpack automatically recompiles your application and refreshes your bundles. So now here at the bottom, you can see Webpack compiled successfully. Now, if you go back to the browser, look, without me even refreshing this page, now we have the new title, Welcome to Angular app. So this is a feature of Webpack called hot module replacement or hot module reloading. So whenever one of the source files is modified, Webpack automatically refreshes your browser. Now let's right click on this page and go to View Page Source. On the bottom of this page, look at these script tags. So all the bundles that Webpack generated, it also injected them into our index.html. So just to refresh your memory, here in index.html, look, we don't have any references to a style sheet or a script file. So this is something that happens at runtime. So Webpack automatically injects these scripts into our index.html. Now let's take a look at this styles.bundle.js. So basically what we have here is some JavaScript, and in the middle of this JavaScript code, you can find the styles used in your application. Now how this works is a little bit complicated, so don't worry about it for now. What I want you to know is that all your style sheets are compiled into a JavaScript bundle. One question that often comes up is what's the difference between AngularJS, Angular 2, and Angular 4? And how did we jump from Angular 2 to Angular 4? Well, AngularJS was introduced in 2010 as a JavaScript framework for building client applications. Soon it gained popularity, and the Angular team started adding new features to the core. But the framework was not designed with the needs of today's applications in mind. Plus, it was overly complex. So Angular team decided to rewrite the original framework using TypeScript, and as a result, Angular 2 came out in mid-2016. This new version is entirely different from Angular 1 to the extent that you can think of it as a completely different framework. Now, this made a lot of developers unhappy because they had a lot of applications built with Angular 1 with each application over a few thousand lines of code that had to be written. But overall, I personally like the direction that the Angular team took and how they rebuilt Angular with TypeScript. This is a much better framework, it's a lot cleaner, and it's a lot easier to understand and to work with. Now, after a few minor upgrades to Angular 2, something strange happened. We were up to Angular 2.3, and then all of a sudden, Angular 4 came out. So a lot of developers, including myself, wondered what happened to Angular 3. We thought we missed something really big here. But unlike Angular 2, Angular 4 was not a new framework with a lot of breaking changes. In fact, it wasn't even a major upgrade. So let me explain what happened. Angular consists of a few different libraries that are distributed as separate node packages via npm. For example, we have the core library that we use in every application. We have Angular compiler. We have Angular HTTP for calling HTTP services. We have Angular router for adding navigation to applications and a few other libraries. Now, all these libraries were versioned the same except the router library. So in order to align these versions and avoid confusion in the future, Angular team decided to go straight to Angular version 4. So in a sense, Angular 4 is not a major upgrade to Angular 2, and you can think of it as Angular 2.4, as simple as that. Now, after all this confusion in the community about Angular versions, the team decided to drop the version suffix and simply call the framework Angular. So now we have two kinds of Angular. We have Angular.js, which is the first generation of Angular written in JavaScript, and it's going to die sooner or later. And we also have Angular, which refers to Angular 2 or later. In our discussions, in our articles, and whenever we want to talk about Angular 2 or later, we should really use the word Angular. Like, I'm an Angular developer, instead of I'm an Angular 2 developer, or I'm an Angular 4 developer. See, it's really weird. We should use versions only when we need to talk about a specific release. For example, when we want to upgrade Angular 4 to Angular 5, then everybody knows what is the scope of this upgrade and what are the potential breaking changes that can impact an application. So this is all about Angular version history. All right, now let me quickly give you an overview of how I have structured this course and how you can get the most out of it in the shortest possible time. So in this course, we have 3 parts: Essentials, Advanced Topics, and the final project. We're going to start the essential part with an introduction to TypeScript and object-oriented programming. This will prepare you to build Angular applications. So then we'll look at Angular fundamentals, displaying data and handling events, components, directives, template-driven forms, reactive forms, consuming HTTP services, routing and navigation, authentication and authorization, deployment, and building real-time applications with Firebase. So these are the essentials that you will use frequently in real-world applications. Then we get into the territory of the advanced topics. And by advanced, I don't mean complicated, I mean anything that is beyond the basics. So in this part of the course, I will cover animations, Angular material, Redux architecture, unit testing, and integration testing. And over the last part, we'll build that e-commerce application that I showed you at the beginning of the course. This part also includes a few sections, and in each section, we'll build one module of functionality in this application. So here we have sections like product management, shopping cart, checkout, and so on. Now, I understand that you might be busy and not have enough time to watch the entire course, and that's perfectly fine. So I'm going to give you a shortcut that allows you to get the most out of the course within the shortest possible time. Start with the essentials. Watch all these sections in sequence, but feel free to skip the section called reactive forms because we're not going to use the materials in this section in our final project. Also, you can skip consuming HTTP services as well as authentication and authorization. You need to watch these sections if you want to build a backend for your application using frameworks such as ASP.NET, Express, Django, and so on. But this e-commerce application we'll build in this course doesn't have a custom-built backend. We use Firebase as the backend, so things are a little bit different here. If this sounds confusing to you, don't worry, I will clarify it in the section about Firebase. So here's my suggestion to you. Watch these sections in the essential parts in sequence, and then move to the final project part. I want you to build this application because that's where you will see all these moving parts coming together. Plus, those sections include tons and tons of tips and techniques that I've shared with you, and these are the things I have learned over the past 17 years of working in the industry as a professional software developer. They really change your thinking about programming and software engineering. I worked really hard for these sections and I want you to watch them. Once you finish the project, then you will have a good understanding of the big picture. Then you can come back and learn about the other sections in the course in isolation, depending on your needs. For example, if you want to learn how to add animations to your applications, you can simply go watch the animation section. Or if you want to learn about reactive forms, you can just go back to that section. So focus on the absolute essentials and then move to the final project. Hi, thank you for watching my Angular tutorial. If you enjoyed this video, please like it and share it with others. Also, you can subscribe to my channel for free new videos every week. This video is part of my complete Angular course with almost 30 hours of high quality content where you will learn everything about Angular from the basic to the advanced topics all in one course, so you don't have to jump from one tutorial to another. In case you're interested, you can get this course with a big discount using the link in the video description. And if not, that's perfectly fine. Continue watching as the next section is coming up. In order to build applications with Angular, you need to be comfortable with TypeScript. So in this section, I'm going to introduce you to the fundamentals of TypeScript and object-oriented programming principles. So by the end of this section, you will have a good understanding of type annotations, arrow functions, interfaces, classes, constructors, access modifiers, properties, and modules. If you're familiar with these concepts and know how to implement them in TypeScript, feel free to skip this section and move on to Angular. Otherwise, you really need to watch every lecture in this section. So now let's get started. So what is TypeScript? TypeScript is not an entirely new language. It's a superset of JavaScript. So that means any valid JavaScript code is also valid TypeScript code. But TypeScript has additional features that do not exist in the current version of JavaScript supported by most browsers out there. For example, in TypeScript, we have this concept of strong or static typing. If you have worked with languages like C# and Java, you know that in these languages, when we define a variable, we need to specify the type of that variable. Now in TypeScript, typing is optional, so we don't have to use this feature. But using this feature makes our applications more predictable, and it also makes it easier to debug them when something goes wrong. TypeScript also brings quite a few object-oriented features that we have missed in JavaScript for a long time. We have the concept of classes, interfaces, constructors, access modifiers like public and private, fields, properties, generics, and so on. You're going to learn about this in this section. Now, another benefit of using TypeScript is that with TypeScript, we can catch errors at compile time instead of at runtime. Well, of course, not all kinds of errors, but a lot of errors. So there is a compilation step involved, and when we compile our TypeScript code, we can catch these errors and fix them before deploying our application. And finally, another benefit of using TypeScript is that we get access to some great tools out there. One thing that I personally love about TypeScript is the IntelliSense that we get in our code editors. Again, you're going to see that in this section. So TypeScript is a beautiful language, and it's basically a superset of JavaScript. So any valid JavaScript code is also valid TypeScript code. Now, the browsers out there, they don't understand TypeScript, and it's very unlikely that they're going to support it in the future. So we need to compile, or more accurately, transpile our TypeScript code into JavaScript. So this is part of building our application. Whenever we build our application, TypeScript compiler kicks in, and it transpiles our TypeScript code into JavaScript code that browsers can understand. Now that's enough introduction. Next, I'm going to show you how to install TypeScript and write your first TypeScript program. In this lecture, I'm going to show you how to install TypeScript and write your first TypeScript program. So here we're in the terminal. We're not going to work with Angular in this section. We're going to purely focus on TypeScript. So first, we need to install TypeScript globally on our machine. So npm install -g, which stands for global, TypeScript. And of course, if you're on Mac, you need to put sudo at the front. All right, beautiful. So I've installed the latest version of TypeScript, which is currently version 2.3.4. Now we can type tsc, which stands for TypeScript compiler --version. Again, you can see that I'm running TypeScript 2.3.4. All right, now I'm going to create a new folder for this section. So let's call this ts hello. Let's go to this folder. Now here I'm going to create a new file and open it with VS Code. So code main.ts. So now I'm going to write some plain JavaScript code. And I want to show you that all this JavaScript code is also valid TypeScript code. So first I'm going to define a function. Let's call this log. That takes a message. And here we simply log that message on the console, like this. Then I'm going to declare a global variable. Let's call this message and set it to this string, hello world. And finally call our log function, message. So this is just plain JavaScript code, right? Now save. Back in the terminal, we need to transpile this TypeScript file into JavaScript. So tsc, or TypeScript compiler main.ts. Now, if you look at the files in this folder, look, we have main.js and main.ts. Now, this transpilation or compilation step, when you're building an Angular app, happens under the hood. So you don't have to manually call the TypeScript compiler. In fact, when you run your application using ng-serve, Angular CLI calls TypeScript compiler under the hood to transpile all our TypeScript code. All right, now let's open our main.js file. So code main.js. So it's exactly the same code that we wrote, but now it's in a JavaScript file. So all JavaScript code is also valid TypeScript code. Now back in the terminal, I can execute this code using Node. So node main.js. And we got the hello world message on the console. So from the next lecture, we're going to look at specific features of TypeScript that we don't currently have in JavaScript. All right, let's explore TypeScript by looking at variable declarations. So in TypeScript, there are two ways to declare a variable. We can use the var keyword, which you have seen in JavaScript, like var number, we set it to 1. Or we can use the let keyword. So let count to be 2. Now, before I explain the difference, I need to clarify that the let keyword is also being added to the JavaScript. So JavaScript has a few different versions. We have ES5 or ECMAScript 5, which is the version of JavaScript supported by pretty much all browsers out there. It's been around for a long time. Now we have ES6, which is a newer version, and it was introduced in year 2015. And from that point, the ECMAScript team, which is the team extending JavaScript, decided to use the year number instead of the version number. So we have ECMAScript 2015, 2016, and 2017. Now in ECMAScript 2015, which is basically ES6, we also have this let keyword. But in case you're not familiar with it, let me explain how it works. So I'm going to define a function. Let's call it do something. It doesn't really matter. Now here I'm going to define a for block. So var, we set I to 0. And as long as I is less than 5, let's increment it. Here we have a block and then log it on the console. Now finally, at the end of this function, I'm going to log this I one more time, but with the label finally. And then I'm going to call this function here. So in the terminal, I'm going to compile this file, main.ts, and also at the same time, run it with Node, main.js. Note that the value of I at the end is 5. So this is the issue we have when declaring a variable using the var keyword. So we have declared I here inside this for block, but it's also meaningful and available outside the for block. Now, if you have worked with languages like C# or Java, you know that we don't have this concept in those languages. In JavaScript, a variable declared with a var keyword is scoped to the nearest function. So in this case, the nearest function is do something. So once we declare I inside this for block, it's available anywhere in this function. Now let's see what happens when we declare this variable using the let keyword. So let. Now look, we immediately got a red underline here, which indicates a compilation error. And this is one of the beauties of TypeScript. When you're writing TypeScript code, you can catch these errors at compile time, before you run your application, before you deploy it. Now let's hover our mouse here. So this is the error, cannot find name I. So now I is scoped to the nearest block instead of nearest function. And this is the proper way to declare variables, which prevents a lot of issues later down the road. Now, I want to clarify something. Let me save this file. Back in the terminal, first I'm going to remove main.js. Now I'm going to recompile our main.ts. Okay, we got our error here, cannot find name I. However, if you look at the files in this folder, we do have main.js. So even though we have a compilation error, the TypeScript compiler still generated main.js. Let's have a look at the content of this file. So this is the code that is generated. So by default, TypeScript compiler compiles our TypeScript code to ES5 or ECMAScript 5, which is the older version of JavaScript that is supported by all browsers out there. Now there we don't have the let keyword. So that's why our compiled code now uses the var keyword. And this is perfectly valid JavaScript code. So I can go in the terminal and simply run this code and get the same output as before. So what I want to clarify here is that TypeScript compiler reports these errors, but still generates valid JavaScript code. So here's the takeaway for this lecture. From now on, anywhere we want to declare a variable, we use the let keyword. Once again, this does not stop the compilation step, but at least we can catch the issues earlier during the compile time. Next, we're going to look at different types we have in TypeScript. In this lecture, I'm going to show you different types we have in TypeScript. So let me start by declaring a variable called count and set it to 5. Now, if I set this to, let's say, a character or a string like A, note that I immediately get a compilation error here telling me that this A string or A character is not assignable to type number. Now we can perfectly do this in JavaScript because in JavaScript we can change the type of variables on the fly, but in TypeScript we get a compilation error. Now once again, I want to clarify that we can perfectly compile this using TypeScript compiler and we will get valid JavaScript code. So if I go to terminal and type TypeScript compiler main.ts. Now look, this is our main.js. So we have this count variable and we have changed its value. We can perfectly execute this, no problem. However, code like this is very likely that it's going to break at some point in the future because chances are we're going to use this count variable inside a for block. So our program is going to break at runtime. We don't want this to happen, right? That's one of the reasons it's better to write the same code in TypeScript so at least we can get a warning during the compilation step. Now, if you hover your mouse over this count variable, look at the tooltip. You can see a colon and number after this count. So this indicates the type of count variable in our program. So here, TypeScript compiler inferred that the type of this variable should be a number because we set it to number 5. Now, what if I declare a variable without initializing it? Let's look at its type. Its type is now any. And that's exactly like the variables we declare in JavaScript. So I can set A to 1, then I can change the value to true and then set it to a string. Even TypeScript doesn't complain about this. So what's the solution? If we don't know the value of a variable ahead of time, that's when we use type annotations. So here we add colon, and after that we set the type of this variable, like number. And then look, on the third and fourth lines, we got compilation errors. Now in TypeScript, we have a few different types. So we have number, which can include any integer or floating point numbers. We have booleans, which can be true or false. We have strings. We have any that you saw earlier. We have arrays. So let's say we want to declare an array of numbers. We would use a number with square brackets. Now we can optionally initialize this to an array like this. Or we can declare an any array, and with this, we can set this to an array with these values: 1, true, A, and false. Of course, it's not a good practice. We want to avoid this, but I'm telling you what is possible with TypeScript. Now we also have another type that I absolutely love, and that's enum. So let's say we are working with a group of related constants, like colors. So in plain old or vanilla JavaScript, we would define constant colors like this. So color red, we can set this to 0. Constant color green, we set this to 1, and constant color blue, set it to 2. Now this is a little bit verbose. In a lot of object-oriented languages, we have this concept called enum. So we can put all these related constants in a container. So in TypeScript, we can declare an enum like this. Enum, all lowercase. We give it a name like color. Now curly braces, and here we set the values. So red, green, and blue. Then we can declare a variable like background color and set it to color dot. Now look, we have IntelliSense here. So this tooltip you see here allows us to complete this code without remembering all the details. And this is one of the things I love about TypeScript. So let's set the background color to color.red. Now in terms of the values, the first element here automatically gets the value of 0. And each subsequent element gets an incremented value. So we don't have to explicitly set these. But as a best practice, it's better to do so, because chances are sometime in the future, someone may come here and add a new color here like purple, and then purple would automatically become 2, and the value of blue would change to 3. So this may break parts of our application. So let me revert this by explicitly setting the values. If somebody adds a new color here like purple, then it will not change the value of blue. Now let me show you something. Let's compile this code and see how we get enum in JavaScript. So TypeScript compiler main.ts. Look at this piece of code here. This is how we can implement the concept of enums in JavaScript. You can see it's very complicated. Now compare this with how we declared an enum here. It's much cleaner. So the more you work with TypeScript, the more you're going to love this language. In this lecture, I'm going to show you the concept of type assertions in TypeScript. So I'm going to start by declaring a variable like message and setting it to a string. Now here we can type message dot, and look, we get this beautiful IntelliSense. And in this tooltip, we can see all the things we can do with a string. So all these items with these purple icons are functions. For example, we have this function called ends with. We can call this and see if this message ends, let's say, with C. And this returns a Boolean. So we can store the result in another variable like ends with C. However, sometimes TypeScript may be a little bit confused about the type of a variable. For example, I'm going to remove this initialization here and initialize this variable on the second line, ABC. Now look at the type of this message variable. It's any, because by default, when we don't set a value, the type is any. Now the problem here is that if I delete this and type period, look, we don't get that IntelliSense anymore. Because ends with is something that we can do with a string. not with an object of type any. So what should we do? In this case, we need to explicitly tell TypeScript compiler that this message variable is actually a string. And this is what we call type assertions. Now, how do we do type assertions? There are two ways. One way is to prefix this variable with angle brackets. And here we put the type, like string. Now we need to enclose both these parts in parentheses, like this. Then, if we press period, we get our beautiful IntelliSense with all the functions or methods available on string objects. Now, there is also another way to do type assertion. So, let's change the name of this variable to alternative way. And here, instead of angle brackets, we use message as string. They're exactly the same. The approach you choose is purely your personal preference. But the first approach is what you see more in a lot of tutorials and code bases out there. Now, I just want to clarify something here. This type assertion does not change the type of this variable at runtime. In fact, it's not going to restructure that object in memory. It's purely a way to tell TypeScript compiler about the type of a variable, so we can access the IntelliSense. Another concept you need to know when using TypeScript to build Angular applications is the concept of arrow functions. So in JavaScript, we can declare a function like this. Let log, we set this to a function. This function takes a message object and simply logs it on the console, like this. Now in TypeScript, there is a shorter way to define this function. So let's call the other one doLog. Now we don't need the function keyword anymore. We can simply add the parameters, in this case message. Then we add this arrow, and that's why we call this an arrow function. And finally, the code block. So console.log message. Now if our function has only one line, we can even exclude these curly braces. So we can make this code a little bit shorter and cleaner, like this. If you have worked with C#, you have seen this before. In C#, we call this a lambda expression. In TypeScript, we call it an arrow function. It's exactly the same thing. Now, if you have one parameter here, you can even exclude the parentheses. But I personally don't like this because I think it makes the code a little bit less readable. So I always like to put my parentheses here to indicate to the reader of this code that these are the parameters. Now, what if we don't have any parameters? We just add empty parentheses. And of course here, we don't have the message. So if you have not seen this before, get used to it. It's a really nice and clean way to define functions. All right, now let's see how we can use custom types in TypeScript. So I'm going to start by declaring a function like drawPoint. So this function takes an X and a Y and simply draws it on the screen. Now, we don't want to worry about the actual drawing algorithm. We just want to focus on the signature of this function. Now, this function is not too bad. Here we have only 2 parameters. But sometimes when working with more complex concepts, we may end up with a function that has so many parameters, like this. This is really, really bad, and it's something you should avoid at all times. In those situations, it's very likely that a group of these parameters, maybe all of them, belong to a single concept. As an example, think of a car. A car has so many different properties. We don't want to pass all those properties to a function like drive car. Instead, we want to encapsulate them inside an object and only pass that one object here. So in this example, instead of passing X and Y here, it's better to pass a point object. And then we can call this function like this, drawPoint. We give it an object with 2 properties, X and Y. So now our function has a cleaner syntax. However, there is a problem with this implementation. Instead of a point object, I can pass a person object that has a name property. And nowhere here, we're getting a compile time error. But we know that this code is going to break at runtime because the algorithm in our drawPoint function is expecting X and Y properties. So what's the solution? Well, let me revert this back. Okay, we've got X and Y. So there are two solutions to solve this problem. One way is to use what we call inline annotation. So just like we can annotate this parameter with a type, like number, we can annotate it with a custom type or a custom object. So here we add curly braces to indicate an object. This object is going to have a property called x, which is a number, and also another property called y, which is again a number. So this is what we call inline annotation. It works fine for simple cases, but the problem with this, as you can see, is that this is a little bit verbose. Also, chances are somewhere else we might have another function that expects a point object. We don't want to repeat this object literal in multiple places. So in those cases, a better approach is to use an interface. If you have worked with object-oriented programming languages like C# and Java, you know the concept of interfaces. We have the same concept in TypeScript. Now, if you have never worked with interfaces, let me show you how they work. So on the top, I define an interface, and I'm going to call this point, curly braces. Then I add x is a number and y is a number. So with this interface, I'm defining the shape of an object. And then I can simplify this declaration and set the type of this parameter to point. This is much cleaner, and we can also reuse this in multiple places. Just one thing, note the naming convention I have used here. So because I'm introducing a custom type, I've used Pascal naming convention. So the first letter of every word in the name of the interface should be capitalized. So here we have uppercase P, not a lowercase p, okay? So when using interfaces, always use Pascal naming convention. So in the last lecture, we used an interface to define the shape of a point object. But there is a problem with this implementation. In object-oriented programming languages, we have this concept called cohesion, which basically means things that are related should be part of one unit. They should go together. This is what we call cohesion. Now back to this example. On the top, we have used an interface to define the shape of a point object. And below that, we have a standalone function. And this is where we have violated the cohesion principle. So the concept of drawing a point is highly related to the structure of a point. It should not be a separate function. Now, if you're going to build a utility library for working with points, chances are you're going to create another function like getDistance that calculates the distance between 2 points. So point A of type point and point B of type point. And this goes to this code block. Again, we have violated the cohesion principle. We have two functions hanging in the air, separate from the point object. Since these concepts are highly related, they should be part of one unit. In object-oriented languages, we call that unit a class. So a class groups properties and functions that are highly related. Now, in this implementation, unfortunately, we cannot move these two functions inside our interface because interfaces are purely for declarations. They cannot include any implementation. In other words, we cannot have the algorithm for calculating the distance between 2 points or drawing a point inside this interface. What we can do instead is to add a function here, a function declaration. So we're going to have a draw function that takes no parameters and returns void, which means it doesn't return anything. Now, you might be asking, why don't we have this point parameter here? Because if all these members, x, y, and draw are part of one unit, we don't need to pass x and y as parameters to the draw function. This function can directly access these properties, x and y, in the same unit. So we don't need this parameter here. Now in interfaces, as I said, we cannot have implementation. We can only have the signature of a function. So with this interface, we're telling TypeScript compiler that our point objects should have two properties, x and y, and a function called draw. The implementation of that is somewhere else. So what should we do now to apply the cohesion principle here? We need to use a class instead of an interface. So on the top, I'm going to change the type to class. And here I'm going to replace this comma with semicolon. So our point class has 3 members. The first 2 members are what we call fields that we use for storing data. And the third member is a function. Now here in this class, we can have the actual implementation of this draw function. So we can simply define it like this: draw, and then add all that logic for drawing a point. Now similarly, we can have another function, get distance, that returns the distance between this point and another point, like this. Again, all that logic will end up here. Now with this restructuring, you can see that everything about a point is in one unit, in one class. So we have the coordinate, which includes x and y, and 2 functions, draw and get distance. Now in object-oriented programming terms, we refer to these members as fields and to these functions as methods. So when a function is part of a class, we call it a method. All right, now with this new implementation, we don't want these 2 functions hanging in the air, so delete. This is a much better structure. Also, we're not going to call draw point like this anymore. So here's our point class. In the next lecture, I'm going to show you how to create an object of this type and call the draw method. All right, so here's our class. Now let's declare a variable of this type. So let point be of type point. And then we can type point dot. Look, we have this beautiful IntelliSense. We have 2 methods, draw and get distance, and 2 fields, x and y. Now in TypeScript, we also have a concept called property, which is different from a field, but a lot of people use these terms interchangeably. Later in this section, you're going to learn the difference between fields and properties. Now, if you want to call the draw method, we simply call it like this. So this draw method is now part of the concept of a point. It's not a function hanging in the air, polluting the global namespace. Now for this demo, I'm going to add a simple console.log here and display the coordinate of this point. So x, now here I want to add the x field, but we cannot use it like this. We need to prefix it with this dot. So that refers to this field in this class. And then I'm going to add y is, once again, this dot y. Now let's compile and run this program and see what happens. So tsc, what should we type here? Main.ts. And we can shortcut by adding this pipe here, type node, and then main.js, okay? We got a runtime error. Cannot read property draw of undefined. So this is the problem. When we call this draw method, this point object was undefined. Because here, unlike the basic types we have in TypeScript, like numbers, strings, booleans, we're dealing with a custom type. When defining an object of a custom type, we need to explicitly allocate memory to it. How do we do that? Well, here where we declare the point object or the point variable, we initialize it using the new operator. So this object is a new point. And here we add parentheses. This is the syntax. Now you can see that we have repeated this point here twice. So we can make this code a little bit cleaner by removing this type annotation. Because TypeScript compiler can infer from this assignment here that the type of this object is a point object. And let's verify that. So look, you're working with a point object. Now, one more time, save. So back in the terminal, TypeScript compiler, main.ts, and then node main.js. Okay, we didn't get an error, but you can see that these x and y fields don't have a value because by default, they are undefined. So we can get back here and set point.x to, let's say 1, and point.y to 2. Now back in the terminal, TypeScript compiler, main.ts. I actually made a mistake earlier. So instead of this pipe operator, we need to use double ampersand on Mac. I don't know the Windows equivalent. So with this, we can combine multiple commands. So node main.js. All right, beautiful. X is 1 and Y is 2. So this is how we use the classes that we define in our programs. Now I want to highlight something here. This point here is a class, but this point here is an object. An object is an instance of a class. As a metaphor, think of the concept of a human. Human could be a class, but when we create instances of this class, like John, Bob, Mary, these are all objects. So that's the difference between a class and an object. Next, we're going to look at constructors. All right, so I've simplified the code from the last lecture. I simply removed the method getDistance because we're not going to use it later in this section. So here on the top, we define a point class, and then below that, we initialize a point object. Now, this code is a little bit verbose because we have 3 lines to create a point object and put it in a valid state. What if this point object had a few other properties that we had to initialize like this? And maybe a few more here. Is there a cleaner way? Absolutely. So let me delete this first. All right. In object-oriented programming languages, we have this concept called constructor. So every class can have a constructor, which is basically a method that is called when we create an instance of that class. So let me show you how it works. In the class, I'm going to add a method. The name of this method is constructor. This is a reserved keyword in TypeScript. Now this method can have parameters. So x, which is a number, and y, which is also a number. And then here in this method, we can initialize these fields. So what should we write here? This dot x, we set it to this x argument that we get here. And similarly, this dot y, we set it to y. Now look, we got a compilation error here. Because when creating a new point object, we need to supply these values. Look at the error. Supplied parameters do not match any signature of call target. So here, we need to supply the values for x and y, 1 and 2. And with this, we can simplify this code and get rid of these 2 extra lines. And here's the end result. Now, what if somewhere else in our program, we don't know the initial coordinate of a point? In other words, what if I want to create a point object without setting these values? Is that possible? Yes, absolutely. But it's a little bit different from how you have seen that in other languages like C# and Java. In C# we can have multiple constructors. In TypeScript, we can't. So the solution for this is to make these parameters optional. So here, after x, I add a question mark, and that makes x optional. And similarly, y should be optional as well. Because once you make a parameter optional, all the other parameters on the right side of that parameter should also be optional. This is a rule by TypeScript and a lot of other programming languages. So now look, we don't have a compilation error when creating a point object without initial values. All right, so here I've created a point object with an initial coordinate. Now, what if in our program, you want to have this rule such that when we initialize a point object, we should not be able to change the x or y values. With this implementation, I can always come here and set point.x to a different value. How can we avoid this? Sometimes we need this feature in our programs because it will make them more predictable. It reduces the chance for bugs. So, how should we prevent the coordinate of this point object to change after it's initialized? Well, in object-oriented languages, we have this concept called access modifiers. An access modifier is basically a keyword that we can apply to a member of a class to control its access from the outside. So in TypeScript, we have 3 access modifiers: public, private, and protected. Public and private are the most common. And by default, all members are public. Let me show you what I mean. So here, in our point class, we have 3 members, right? We have 2 fields and 1 method. So when we create a point object and type point dot, look, these are the members of the class. And because they are all public, we can access them here. And that's why we can see them in the IntelliSense. However, I can go here and prefix this field with the private keyword. Now, once we create this point object, if I type point dot, look, x is not in the list. It's not accessible. It's private. So if we try to set point.x to 3, look, we have a compilation error in TypeScript. It says property x is private and only accessible within class point. Now with this technique, I can go here and apply the private keyword on the y field as well. And now, once I initialize a point object, I can no longer change its coordinates. I can only call the draw method. Okay? So this is why we use access modifiers, to control access to certain members of a class from the outside. You can apply these access modifiers on fields, properties, and methods. Now, by default, if you don't set an access modifier, it's assumed to be public. So here, the draw method, as you know, is public. I can also add the public keyword here, but this is redundant. It's just making my code noisy. So you don't really need to add this. It's better to keep your code short and clean and use the private access modifier only when you need to. Next, I'm going to show you one of my favorite features of TypeScript around access modifiers. As you write code with TypeScript, you see constructors that follow a pattern like what you see here. So here we have two parameters in our constructor, and we use these two parameters to initialize the fields in this class. The code looks a little bit redundant. This.x equals x and this.y equals y. TypeScript has a fantastic feature that helps you achieve the same thing with less code. So here, we can delete these two fields here. And in our constructor, we can prefix our parameters with an access modifier. So here I want to have two private fields, x and y. I can simply prefix these with the private keyword like this. So TypeScript compiler will generate these fields for us. And also, we don't need these ugly, repetitive assignments either. So if we prefix a constructor parameter with an access modifier, whether private or public, TypeScript compiler will generate a field with the exact same name, and it would also initialize that field with the value of this argument. It's one of my favorite features, and you're going to see that a lot in this course. Now, I'll clarify something before I finish this lecture. In this case, our fields were private, but if they were public, we would use the public keyword here. So this means when we create a point object, we can access the x field. Okay? So I'm going to revert this back to the private. All right, now this implementation has a tiny problem. We can set the initial coordinate of this point, and we can also draw it, but there is no way for us to read the coordinate. So I cannot access point.x here to display it to the user. What's the workaround? Well, one simple solution is to define a method like this, get x, and here we simply return this.x. Because in this class, we do have access to all the private members of this class, but we cannot access them from the outside. Okay? Now here, I can always call point.getX to get the x value and display it to the user. Now let's talk about another use case. Maybe we want to give the user the ability to set the initial coordinate here, but we also want them to be able to change this coordinate later only if they provide a value within a given range. What do I mean by that? Let me show you. I'm going to define another method here, set x. Now this method is going to get a value. That's the new value for the x field. Let me scroll down. Now here, first we can do some basic validation. So if value is less than 0, we want to throw an error. Throw new error. Value cannot be less than 0. Otherwise, we want to set this.x to this new value. Okay? Now with this implementation, we can always change the value of the x field like this. Point.setX we set it to a new value. Now, if you have a use case like that in your applications, you can use what we call a property. So in TypeScript and in a lot of object-oriented programming languages, we have a concept called property, which is exactly for this very use case. So look at how I can define a property here. We start with a keyword, which is get or set, and then the name of the property, which is in this case x. And after that, we're going to have parentheses, just like a method. Okay. Now, similarly, I'm going to change this to set with a space. So we have the set keyword. And here it's like we have a function, a method. Now, what is the difference? The difference is that we can use these properties like fields. So here, I can read x like this. Dot. Note the icon of x. It's the same icon we have for fields. It's not a method anymore. So we can read x. And we can also set it like this. Point.x, we set it to 10. We don't have to call a method like this. It's a cleaner syntax, okay? So this is what properties are for. If you have private fields that you want to give maybe a read-only access to the outside, or if you want to give the consumer of your classes the ability to set the values, but you want to have some basic validation, that's when you use a property. Now, in this case, if I want to give only the read-only access to this underlying field, I can simply comment out the setter. So we call this method a setter and the other method a getter, okay? And now look at this compilation error. We cannot change the value of x. Now let's bring this back. One last thing before we finish this lecture. So here I have used a capital X for the name of my x property. In JavaScript and in TypeScript, we use camel notation to name our fields. So that's why earlier we defined this private field here using camel casing notation. Camel casing means the first letter of the first word is lowercase and the first letter of every word after is uppercase. Now, what should we do to use camel casing notation for our properties? If I name this the lowercase x, it clashes with the existing field. So let me revert this back. A convention we use to solve this problem is to prefix the name of the underlying field with an underline. So let's rename this using F2 and prefix it with an underline. Okay. Now similarly for the y parameter or the y field, I'm also going to use underline y. Then we can rename this property from capital X to lowercase x. Once again, we press F2, lowercase x, and note that both instances, both the getter and the setter, are updated. Now, we can work with this x property exactly the same way we use the x field. So here's the lesson. A property looks like a field from the outside, but internally it's really a method in the class. Well, more accurately, it's either one method, which is a getter or a setter, or a combination of a getter and a setter. All right, I've simplified the definition of the point class. I removed the properties. So we have a simple constructor and the draw method, and we're using this point class below its definition. Now, this is a very simple program with only one file, but a real-world application consists of tens or hundreds of files. We don't want to write all the code in one file like main.ts. So ideally, I want to move the definition of this point class somewhere else in a file like point.ts. So here in this project, I'm going to add a new file, point.ts. Now back in main.ts, I'm going to select all this code, cut it, and move it to point.ts. Now, in TypeScript, we have this concept called modules. Now, what a module is requires a little bit more explanation, but for now, let me give you a simple, pragmatic definition. In TypeScript, you can think of each file as a module. So in this program, we can say we have two modules, but this is not quite accurate because these files are not modules yet. So in point.ts, we have defined this class called point, but this is not accessible anywhere outside this file. So this file defines its own scope. In order for us to use this class somewhere else in our program, we need to export this to the outside. So we add the export keyword here, and now this is visible outside this file. Now that we're exporting something on top of this file, from TypeScript's point of view, this file is a module. Now we need to go back to our main.ts and import this class so we can use it. So back in main.ts, look, we have a compilation error. Cannot find name point because we have not imported this into main.ts. So on the top, we write import. In curly braces, we add the name of the types we want to import. In this case, point. Now, if there are multiple types we want to import, we separate them using comma. Okay? So we import point from. Now here we put the name of the module in quotes. What is the name of the module? It's the relative path to that module from this file. So both these files are in the same folder. We can use period slash, which refers to the current folder. And then point is the name of our module. So it's not point.ts. Look, we get a compilation error. So the name of our module is point. Now we no longer have a compilation error here, and we can create an instance of this point class and use it. Now, there is a lot more to talk about when it comes to modularity in TypeScript, but that's all you need to know for now in order to start building applications with Angular. Because in Angular framework, we have a lot of types that are exported, so we need to import these into our TypeScript files and use them. You're going to see that a lot in this course. The only difference is that Angular modules are defined in a different way, so we don't add the relative path to these module files, because these files are not really part of our application. They're somewhere inside node underline modules folder. So when it comes to importing types defined in Angular, we use the library name as the module name. For example, one of the libraries is @angular/core. Okay? So here's the lesson. In TypeScript, we divide our program into multiple files. In each file, we export one or more types. These types can be classes, functions, simple variables, or objects. And wherever we need to use these types, we need to import them first. When we have an import or export statement on top of a file, that file is a module from TypeScript's point of view. In Angular, we also have the concept of modules, but Angular modules are a little bit different. They're not about organization of code in different files. They are about organization of your application into smaller functional areas. You're going to learn about Angular modules in the next section. I love your enthusiasm for learning Angular. As I told you before, this tutorial is part of my complete Angular course, where you will learn everything about Angular from the basic to the advanced topics, all in one course. You seem to be determined enough to learn Angular, and I'm so excited to see you made it this far. So I highly recommend you to click on the link in the video description and enroll in my complete Angular course. So thank you for watching. If you enjoyed this video, please like it and share it with others. And finally, subscribe to my channel for free new videos every week. Have a great day. In this section, we're going to look at the fundamentals of building applications with Angular. By the end of this section, you will have a basic understanding of Angular building blocks, such as components, templates, directives, and services. So now let's get started. So now that you have some basic familiarity with Angular, let's look at the building blocks of Angular apps. At the heart of every Angular app, we have one or more components. In fact, in a real-world app, we have tens or hundreds of components. But what is a component? A component encapsulates the data, the HTML markup, and the logic for a view, which is the area of the screen that the user sees. Let's look at a real-world example. Imagine we're going to build a website like Udemy. So on this page, we have a navigation bar, a sidebar, and an area to display the list of courses. Now, we can think of all this as one view or one component, or we can break this view into smaller, more maintainable, and potentially reusable components like navbar component, sidebar component, and courses component. Similarly, in courses component, we want to display one or more courses. Potentially, we can break up this component into smaller components. And also, to take this to the next level, each course component can include a rating component. Now we can reuse this rating component in multiple places in the same app or in an entirely different app. As you see, Angular embraces component-based architecture, which allows us to work on smaller and more maintainable pieces that can also be reused in different places. So once again, a component encapsulates the data, the HTML markup, and the logic for a view, which is an area of the screen that the user sees. Every application has at least one component which we call app component or root component. A real-world Angular app is essentially a tree of components starting from the app component or the root component. Now, in Angular, we also have another concept called modules. A module is a container for a group of related components. Every Angular app has at least one module which we call app module. As your application grows, you may want to break that module into smaller, more maintainable modules. So in our Udemy example, we can potentially have modules like course module, which includes all the components for displaying courses. We can potentially have another module like messaging module, which includes a bunch of components for the area of the website where you can send private messages to your instructors. We can have an instructor module, which includes the components for instructors' dashboard that you don't see, and potentially admin module, which is the area of the Udemy website managed by the Udemy staff. As an analogy, think of a supermarket. In a supermarket, we have different aisles for different products. We have a section for fruits and vegetables. We have another section for snacks, another for hardware, and so on. The bigger the supermarket, the more aisles we have. In a tiny grocery store, we have probably one or two aisles at the most. The same applies to our Angular apps. So if you're building a simple application, we have only one module, which we call the app module. But as our application grows in functionality, we may need to break that module into smaller modules, with each module responsible for a specific area of our application. In that module, we have a bunch of related components, okay? So this is the big picture. As we go through this course, you will learn about these building blocks in more detail. All right, now let's see these components in action. There are basically 3 steps you need to follow in order to use a component. First, you need to create a component. Second, you need to register that component in a module. And third, you need to add an element in your HTML markup. Let me show you what I mean by this. So, back in our first Angular project, first of all, make sure to run ngserve to serve this application. So now if you head over to localhost port 4200, this is what you see. Beautiful. Now back in VS Code, I'm going to create a new component. So let's open up the file panel. Here in the source folder, under app, here I'm going to add a new file. Now let's imagine I want to create a component to display the list of courses. So look how I named this file. courses.component.ts. This is the convention that we use when building Angular applications. Now, if the name of the component has multiple words, we separate them using a hyphen. For example, if you're building a component called course form, you would call this course-form, and then .component.ts, okay? So courses.component.ts. Now here we start by creating a plain TypeScript class. So class courses component. Once again, look at the naming convention. Here I'm using the Pascal naming convention. So the first letter of every word should be capital. And also by convention, we use the suffix component in the name of the class. So here's our class. In order for Angular to see this class, first we need to export it. Now so far we have only a plain TypeScript class. This is not a component. In order to convert this to a component, we need to add some metadata to it that Angular understands. We use a decorator to achieve this. In Angular, we have a decorator called component that we can attach to a class to make that class a component. So first we need to import this decorator on the top. So import curly braces, component, from, now the name of the library. So at Angular/core. This is the core library of Angular that you're going to see a lot in this course. So here we import the component decorator, and then we need to apply it to this TypeScript class. Now look at the syntax. We use @, component, and then call this like a function. So this is what we call a decorator function. Now this function, as you see here, takes an argument. So here we pass an object. And in this object, we add one or more properties to tell Angular how this component works. For example, one property that we use quite often is selector. So selector. And we set this to a CSS selector. So in CSS, if I want to reference an element like this, I use a selector like this. If I want to reference an element like a div that has a class called courses, my selector would be .courses, right? And if I want to reference an element with the ID courses, this is my selector. Just basic CSS, okay? So here we want to reference an element called courses. Why? Because with components, we can extend HTML vocabulary. So we can define new elements like courses, and inside that we will have the list of courses. Or in the future, we can define a custom element, a custom HTML element called rating, and wherever we use that, Angular will render a rating component, okay? So let's delete this. My selector for this component is courses. Now the second property we add here is template, and that's the HTML markup we want to be rendered for this component. Now here I want to render something very simple, so let's just add an h2 element and call this courses. In a real-world application, our templates can be several lines of code. In that case, we can put them in a separate file, and I'm going to show you how that works later in the course. So this is a basic component in Angular. That was the first step. The second step is to register this component in a module. Now currently our application has only one module, which we call app module. Let me show you where that is. So back here, in the app folder, look, we have app.module. Now, once again, here we have 3 import statements on the top, so nothing special here. On the bottom, we have a TypeScript class called app module. And note that this class is decorated with another decorator function called ng module. So with this, we convert a plain TypeScript class to a module from Angular's point of view. Now, don't worry about all these properties here, like declarations, import, providers, and bootstrap. You're going to learn about them later in the course. What I want you to focus on now is this property, declarations. And this is where we add all the components that are part of this module. So by default, when we generate an application, we have one component called app component, and you can see that component is part of this module. Now I'm going to add our new component here. So courses component. So whenever I type the name of a class here and press enter, it automatically imports it on top of my file. So import courses component from, and here's the name of our TypeScript module. So period slash, which refers to the current folder. And here's the name of the file, courses.component. Now note that here we don't have .ts. In fact, if you add that, TypeScript component doesn't like that. So the name of the module is just the name of the file without the extension. So if you want to add this plugin to your VS Code, simply go here and in the extension search box, search for auto import. So currently I'm using auto import 1.2.2. Simply install it and then you'll have to restart VS Code. All right, so here's our second step. Now the third step. Back to our component. So this is the selector for this component, which means anywhere we have an element like courses, Angular is going to render the template for this component inside that element. But where are we going to add that element? Let me show you. So back here in the app folder, we have this app.component.html. This is the external template for our app component. Let's have a look. So all this markup you see here is for rendering the home page. And this is what we get. Now I want to simplify this. I'm going to get rid of all this markup, add a simple h1, call this Angular, and below that I'm going to add our custom element, courses. So when Angular sees this element, it's going to render the template of our courses component. All right, now back in the browser, this is our new homepage. So let's right click this courses element and inspect this. So look what we have here. We have this h1, and below that we have our courses element. And inside this, you can see we have the template for our courses component. So this is how Angular applications work. As another example, look at this app root element inside the body element. Where is this app root? Well, back in the source folder, look at index.html. So this is the basic template for our application, right? Now, inside the body element, we have an element called app-root. This is a custom element because we don't have an element in HTML called app-root. So from Angular's point of view, we should have a component with a selector for this element. And that's our app component. Let's have a look at that. So back in the app folder, let's look at app.component.ts. So here's our root component, our app component. Look at the selector, app-root. So whenever Angular sees an element like that, it's going to render the template for this component inside that element. In this case, our template is external. So we have template URL, and you can see the name of our template file, app.component.html. So that's why inside app-root, here we have the template for app component, which includes an h1 and the courses element. All right, let's quickly review what we have done so far. So we created this courses component here. Then we registered this in app module. So here in app.module, we added our component inside the declarations array, and then finally use this component in the template for app component. So let's quickly review. app.component.html, we added this courses element here. 3 steps, okay? Now, there are 2 problems with this approach. The first problem is that this approach is a little bit tedious. There are so many steps. So first we had to create this TypeScript class. Then we had to import this component decorator on the top. And next we had to apply it on this TypeScript class. There is so much boilerplate code here. Now, the second issue is that if we forget the second step, our application is going to break. Let me show you what happens. So let's go to app.module. I'm going to delete this line here. Now let's see what happens. Back in the browser, we got a blank page. So now we need to look at the console tab of Chrome Developer Tools. So right click anywhere on the page, inspect. So we can see we have 2 errors here. We can see the details of these errors in the console tab. So here's the error. Courses is not a known element. So if you don't register a component in a module, Angular doesn't know about it. And it doesn't know what to do with this courses element because this is not a native HTML element. So now let me show you a quicker and more reliable way to create an Angular component. We need to go back to the terminal, but look, our terminal is already busy. It's serving the application. So we either have to open a new terminal window, or we can actually open a terminal window inside VS Code. So back here, if you press Control and backtick, which is the character before the number 1 on your keyboard. Look, we have a terminal window here. And this is much easier to access than going back and forth between different windows. So here we can use Angular CLI to generate a component. So just like how we generated an application with ng new, we can also generate a component with this ng. So the syntax is like this: ng space G, which is short for generate, and C, which is short for component. And then the name of the component. Let's say we want to create a component called course. So of course, look at what happened. Angular CLI created a directory called course, and inside this directory added 4 files. A CSS file for storing the style sheets for this component, an HTML file for storing the template, a spec file, which is for writing unit tests for this component, and finally a TypeScript file, which is the actual component itself. Now, what is interesting here is that it also updated app.module and registered this new component. Let's have a look. So we can close this terminal window using the same shortcut, which is Control and backtick. Now we can open the Files panel using Command and B on Mac or Control B on Windows. Okay, look at app.module. So look, inside the declarations array, now we have course component. So this way, we don't have to remember to come back here and register our new components. Now, before we move on, let me just quickly add our courses component that I removed earlier. Okay. Now, back in the Files panel, this is the folder for our new component. So in this folder, we have these 4 files. Now let's take a look at the TypeScript class. It has all the boilerplate code that we wrote earlier, plus a little bit more. So here we're importing the component decorator, and on init, which is an interface, we're going to look at this later in the course. We have this component decorator applied to our TypeScript class. We have a selector. We have the URL of our template file, as well as the URL of our style sheet file. So Angular CLI saves us a lot of time. Now, as we go through this course, I will show you how you can use this tool to generate other building blocks for your applications. So earlier I told you that a component encapsulates the data, the logic, and the HTML markup for a view. So in this example, in our courses component, we have the HTML markup, but we don't have any data or any logic. So let's extend this example and take it to the next level. I want to define a field in this class to hold the title of this page. So title, I'm going to set this to list of courses. Now I want to display this title in our template dynamically. So I'm going to remove this hard-coded label here. In Angular, we have this special syntax, double curly braces, and we use this to render something in our template dynamically. So here I can put this title field. This expression will be evaluated at runtime, and the value of this title field will be placed in our DOM. Now, if the value of this title field changes at some point in the future, Angular will automatically update the DOM. This is one of the beauties of Angular framework. So here we have this concept of data binding. So we are binding our view to a field in this component. Whenever the value of that field changes, the view is automatically notified and updated. All right, now let's save the changes. Back in the browser. All right, here's our new title. Beautiful. Now back here, we don't always have to put the name of a field here. We can write any simple JavaScript expressions. For example, I can put a string here, title, colon, and then concatenate this with our title field. Save. Look, this is our new title. Here we can also call a method in this class to get some value. For example, let me define a method, getTitle. And here I'm going to return this, the title. Now, here we can simply call our new method, getTitle, like this, and we'll get the exact same result. There you go, list of courses. So this special syntax here, we call it string interpolation. In the next lecture, I'm going to show you how to render a list of courses here. All right, now let's take this example to the next level. Instead of displaying a simple title field, we want to display the list of courses. So first we need a field to hold the list of courses. So courses, we set this to an array with 3 items, course 1, course 2, and course 3. Now this is a simplified example. In a real-world application, instead of simple strings here, we would have objects. But don't worry, we're going to get there. Now we want to display these in our template. How should we do that? First, we need to change this single quote to the backtick character. So delete backtick. Backtick is the character before number 1 on your keyboard. Let me change this as well. Now, the benefit of using the backtick is that we can break up this template into multiple lines and make it more readable. So I want to put this h2 here. And below that, I want to add a UL and a bunch of list item elements like this. Now, we want to repeat this li for each course. Now, for that, we need to use one of the Angular building blocks called directive. We use directives to manipulate the DOM. We can use them to add a DOM element or remove an existing DOM element or change the class of a DOM element or its style and so on. So here, we're going to use a special directive called ng_for. We use it like an attribute in HTML. So we set it to a string, and here we're going to write some expression. Now, before going any further, we should prefix this attribute with an asterisk. This is a special syntax in Angular, so whenever you're using a directive that modifies the structure of a DOM, you should prefix that directive with an asterisk. In case you're curious about the reason, I have covered it later in the section about directives. So for now, just remember, whenever you are using a directive that modifies the structure of the DOM by adding or removing an element, you need to prefix that with an asterisk. Now here we want to write an expression similar to what we write in for each blocks. So let course of courses. What does this mean? With the let keyword, we are defining a variable. So the name of our variable is course. This is like a loop variable in JavaScript. Of is a special keyword, and courses is the field in this class that we are iterating over. So when Angular sees this expression, it's going to iterate over the courses field, and in each iteration, this course variable will hold the value of one course at a time. Now, inside this list item, we want to display this course. So once again, we use string interpolation, double curly braces, and add this course variable here. Let's look at the result. Save. Back in the browser, and here we have the list of our courses. Beautiful. Now, in most real-world applications, we get these courses from the server. And for that, we need to use another building block of Angular called a service. And that's the topic for the next lecture. All right, now we have the list of courses here. But in a real-world application, most of the time, we get these courses from the server. So instead of hard coding them here, we need to call an HTTP endpoint to get the list of courses. Now here we have two options. One is to add the logic for calling an HTTP service here in this component. But there are a couple of problems with this approach. The first problem is that this logic is going to tightly couple this component to that HTTP endpoint. Now in the future, when we want to write unit tests for this class, we don't want to be dependent upon a live HTTP endpoint, because this is going to make it harder to execute those unit tests. So we want to create a fake implementation of an HTTP service. So this is the first issue with writing this logic inside this class, inside this component. It's going to tightly couple this component to that HTTP endpoint. The second issue is that maybe somewhere else in the application, we're going to have another page where we display the list of courses. Maybe it's part of a dashboard. Maybe it's somewhere for an admin. With this implementation, we have to repeat this logic, the logic for consuming that HTTP service in multiple places. And that's not good. And finally, the third issue with this implementation is that a component should not include any logic other than the presentation logic. That is the logic behind this view. What should happen when we click a button, when we select an item from a drop-down list, and so on. Details of how courses are retrieved should be delegated somewhere else in our application. So where should we implement that logic? In Angular, we use services for that. So we're going to define a separate class, which we call a service, and there we'll add this logic for getting the list of courses from an HTTP service. Then we can reuse this class in multiple places. So let me show you how to do that. Here in the app folder, I'm going to add a new file. Now look at the naming convention. Courses service.ts. So the name of our service is courses, and by convention, we have the word service in the file name, and finally .ts. When creating a component, we use courses.component.ts. So note the difference. Now here, once again, we want to export a plain TypeScript class. So export class courses service. So once again, by convention, we add the word service as a suffix in the class name. Now when creating components, we decorate this class with the component decorator. Remember, component. But in Angular, we don't have a decorator for services. So a service is essentially a plain TypeScript class. So delete. Now here we want to add a method for getting the list of courses. Get courses. For now, we don't want to get distracted with the complexity of consuming an HTTP service. So let's just return the same array that we had in our component, and later I will show you how to consume an HTTP service. So back in our component, I'm going to select this array here, cut, back in the service, and simply return it from this method. Now imagine here in this method, we have that logic for consuming an HTTP service. With this implementation, we can reuse this class, we can reuse this logic in multiple places in our application. And also, this will separate or decouple our component from this logic. So back in our component, here we're not going to have any logic for consuming an HTTP service. And this allows us to unit test this class without dependency upon that HTTP endpoint. So while unit testing this class, we can provide a fake implementation of that service. Now, if that's too complicated, don't worry about it. Unit testing is something for the future. Okay, now we have a service. We need to use this service in our component. How? That's the topic for the next lecture. Okay, now we have a service to get the list of courses from the server. We need to use this service in this courses component. So first we need to add a constructor here, constructor, because a constructor is where we initialize an object. So here we need to create an instance of our courses service, something like this. Let service be new courses service. Once again, I'm using the auto import plugin. So when I press enter, it automatically adds the import statement here on the top. So import courses service from current folder courses.service. All right, now back in the constructor. So we have a service, and then we can initialize this courses field like this. This.courses, we set this to service.get courses. Let's test the application and make sure everything works up to this point. Save. Okay, we get the same list. Beautiful. However, there is a problem with this implementation. The first problem is that by using this new operator here, we have tightly coupled this courses component to the courses service. So this is exactly like the problem we had earlier. If we implemented the logic for consuming an HTTP service inside this component, we wouldn't be able to unit test this class. Now we put this logic in a different class, courses service, but because we're directly creating an instance of this class here, we're still tightly coupled to that implementation. The other issue here is that if in the future we decide to add a parameter to the constructor of courses service, we have to come back here and anywhere else in our application where we have used this courses service and add a new argument, like 1. So anytime we change the constructor of this service, we end up with multiple changes in our application code. So this is very fragile. So what should we do? Well, instead of recreating an instance of the courses service, we can ask Angular to do that for us. So we can delete this line here and add a parameter in this constructor, call it service of type courses service. With this, when Angular is going to create an instance of our component, it looks at this constructor, it sees that this constructor has a dependency This dependency is of type courses service. So first it creates an instance of the courses service and then passes that to this constructor. Now with this implementation, if we change the constructor of courses service and add a new parameter, we don't have to modify 100 places in our code to reflect the change. Angular would automatically instantiate a new courses service object. The second benefit of this implementation is that when we're going to unit test this courses component, instead of supplying an actual courses service to this constructor, we can create a fake implementation of this service that doesn't use that HTTP service on the backend. In other words, we have decoupled our courses component from courses service. So here's the lesson. When you use the new operator like this inside a class, you have tightly coupled your class to that implementation. You cannot change this at runtime. But when you add that dependency as a parameter of a constructor, you have decoupled that class from that dependency. Now, we're not done yet. We need to instruct Angular to create an instance of courses service and pass it to our courses component. This concept is called dependency injection. So we should instruct Angular to inject the dependencies of this component into its constructor. As simple as that. That's dependency injection. A lot of people think dependency injection is so complicated, but it's really a $25 term for a 5-cent concept. So dependency injection means injecting or providing the dependencies of a class into its constructor. Now, Angular has a dependency injection framework built into it. So when it's going to create an instance of a component, it can inject the dependencies. But in order for that to work, we need to register these dependencies somewhere in our module. So let's save the changes. Now we need to go to our app.module. So here's app.module. Okay, look at this ng module decorator. Here we have a property called providers, which is set to an empty array. In this array, we need to register all the dependencies that components in this module are dependent upon. For example, our courses component is dependent upon courses service. So we need to register courses service as a provider in this module. So here I'm going to add courses service. Now, if you forget this step, dependency injection is not going to work. Let me show you what happens. So I'm going to comment out this line, save, back to the browser. We get a blank page, so that means something is wrong. Let's open up Chrome Developer Tools with Shift, Command, and I on Mac, or Shift, Control, I on Windows. Look at this error, no provider for courses service. This is an error that you might see quite often when building Angular apps. So the error is telling us that we have not registered courses service as a provider in our module. So back in app module, I'm going to add this courses service here, save, back in the browser, and we have the list of courses. Now, one more thing before we finish this lecture. When you register a dependency as a provider in a module, Angular will create a single instance of that class for that entire module. So imagine in this module, we have 100 components, and 50 of these components need the courses service. In the memory, we're going to have only a single instance of courses service, and Angular will pass the same instance to all these components. This is what we call the singleton pattern. So a single instance of a given object exists in the memory. So a quick roundup. Back in our component, we added courses service as a parameter in the constructor, or in other words, as a dependency of this class, and then registered this as a provider in our app module. With this implementation, when Angular is going to create an instance of this component, first it will instantiate its dependencies, and then it will inject those dependencies into the constructor of this class. And this is what we call dependency injection. All right, now let me show you a quick way to create a service in Angular. So we go to the terminal. Once again, you can switch to the terminal window, or you can press Control and backtick in VS Code. So here we have a small terminal window. We're going to use Angular CLI to generate a service. So ng, g for generate, Previously, we used C for components. Now we're going to use S for services. Imagine we're going to create a service for sending emails. This service is going to call an HTTP endpoint somewhere for sending these emails. So let's call this email. And note that here I just add the service name. I don't need to add .service. Okay? So this generates two files for us. One is the actual service file, and the other is a spec file, which includes some boilerplate code for writing unit tests for that service. So in the app folder, look, here's our new service, email.service.ts. So we have a plain TypeScript class called email service, but there is something extra here that you didn't see before. We have this injectable, which is another decorator function, similar to the component decorator function. Why do we need this here? We would need this decorator only if this service had dependencies in its constructor. For example, imagine here we had a dependency like log service of type log service. In this case, we need to apply this injectable decorator function on this class, and this tells Angular that this class is an injectable class, which means Angular should be able to inject dependencies of this class into its constructor. Now, we didn't use this decorator when defining components, because when we use the component decorator, that decorator internally includes this injectable decorator. So that's all about injectable. And by the way, note that this decorator function is defined in Angular/core library. All right, now I want you to use what you have learned in this section and build a page like this. So apart from the main heading of our application, we have a heading that includes the number of authors. So here we have 3 authors, and below that, we have the name of these authors rendered using UL and LI. So use Angular CLI to generate a component and a service and write all the necessary code to render a view like this. You can see my solution in the next lecture.
I love your enthusiasm for learning Angular. As I told you before, this tutorial is part of my complete Angular course, where you will learn everything about Angular from the basic to the advanced topics, all in one course. You seem to be determined enough to learn Angular, and I'm so excited to see you made it this far. So I highly recommend you to click on the link in the video description and enroll in my complete Angular course. So thank you for watching. If you enjoyed this video, please like it and share it with others. And finally, subscribe to my channel for free new videos every week. Have a great day.